Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today, my group 6 from session 4, want to presenting about our electrical machine project entitled Characteristic and Efficiency Analysis of an Induction Motor. Me, Zul Idaham with my teammates Ahmad Ifan, Fitri Muhaimin, Haris Saifuddin, Muhammad Waliuddin, and Muhammad Hazmi.
For the problem statement of the project, although some of the systems, such as motor induction system, are a man-made system, its exact behavior cannot be determined given current and past input to the system. This uncertainty in such systems is due, in large part, to the complexity of the system in question. Planners' models based on the original manufacturer's information may not be accurate enough after few years operation. In other situations, some simple man-made system deviate from its design behavior due to aging, wearing out, or change in a system. Parameter that was assumed to be static. Induction motor parameters change with temperature, frequency, and saturation.
Now, for the objective, a project report regarding an exploration, the main characteristic and efficiency of an induction motor during its operation with load change in MATLAB environment. The objective of the project is, the first, to identify the unknown machine parameters in induction motor. The second is to illustrate the analytical result and to demonstrate the practical capabilities. The third is approaching the MATLAB environment to identify the induction motor characteristic, and the last one is demonstrate and analyze the pattern of torque, power, and efficiency versus speed.
Okay, for the methodology, procedure of modeling work and coding in the MATLAB environment. First, set up the parameter that we use and do the manual calculation of main characteristic value. Second, do research on the title of project and find any related to the analysis of main characteristic induction motors. And third, choose the suitable formula, identify whether in polar form or rectangular form. And fourth, do a flowchart and create the script on MATLAB software. Make MATLAB Kursat as reference of doing this script. And fifth, get the result by plotting the required graph. Do the analysis, discussion on it, trial and error if must. And lastly, insert on official project report and do the summary and conclusion.
Okay, my name is Muhammad Hazmi bin Ialim. I will speak about the flowchart. The figure shows the project based on step to get the output result. First, we start do manual calculation. Set up the parameter at MATLAB script. Calculate with the bracket, R to bracket. Start S max and T max. Then display answer on command windows. Then compare display answer and manual. If no, we need to restart again. And if yes, calculate torque speed characteristic, declare formula and M and WM. Then plot torque speed graph, calculate additional resistance on rotor. Then display additional resistance on rotor. After that, display answer on command windows. Then plot torque speed added resistance graph, calculate the current, input, converted and output power. Then plot P convert speed and P out speed graph. Next, calculate efficiency, and the last one is plot efficiency speed graph. And yeah.
Okay, for the coding demonstration, firstly we need to declare the parameter that we use in this project. So we declare the R1, S1, R2, S2, Sn, V, and we face with the formula divided by square root 3, frequency, number of poles, synchronous speed in RPM and R correct per second. So the second one, we use the formula to calculate the V-Thevenin and set the impedance. So after that, we calculate the starting torque, maximum slip, and maximum torque, which is the total torque. Display the answer, and after that, we declare to calculate the torque speed characteristic, and which is an M and a mechanical speed, and After that, we calculate the torque versus speed, which is to show the figure that torque speed characteristic and power speed characteristic. So this is formula for torque speed and formula for power speed characteristic. After that, we answer the next question, which is what the additional resistance that we have to put to the rotor side to achieve the pull out on the starting torque. So we get the value and we display. After that, we show the graph, which is we replace the new resistance, show the graph that additional resistance. After that, we use to show to calculate the input power, the air gap power, converted power, and output power. So that we calculate the efficiency. After that, we plot. So when the plotting, we run the simulation. So on the command window, they show the result. The result, which is Thevenin voltage, impedance Thevenin, and the starting torque, state 4 maximum torque, pull out torque, and the result 3, which is additional resistance calculation value. So the additional is 1.3399 ohms, and the R new is 1.8439 ohms. So for the graph that we have done, which is for figure 1, the torque speed characteristic, we have the starting torque, pull out torque, and the ending of the torque. So there is no pull out torque. Pull out torque is the minimum torque when they develop the induction motor. So the second graph is power speed characteristic. The characteristic is starting by 0 and have the maximum output power. Okay, that's all. And figure 3 to show that the additional resistance. Figure 3 additional resistance graph. So pull out on the starting torque, and the figure 4, which is to comparison between the additional resistance and the original resistance. And figure 5 comparison is P vs speed and torque vs speed. And figure 6 induction motor vs speed, and so it is 20%. So at this one is 20% and this one is 0%. So the decreases and the value. So this is in speed. Okay, figure 8 to show the converted power versus mechanical speed. This is in sleep, it is 20%, which is starting by 32 kilowatt. And this in speed, so same, this is 20% of sleep. And the figure 10, which is output power gets speed in sleep, which is this is 20%, this is 0%, so they decrease, and the starting value starting lower than the converted because they lost they minus the losses of the induction motor. So this in speed, same figure. So this is figure 12 is the comparison between the input power, converted power, and output power. So figure 13, which is efficiency, speed, which is range 100%, 0 to 100% efficiency, and this is the sleep, 20% sleep. And the figure 14 is in speed, mechanical speed. So the same one. This is the reason. Okay, that's all.
So lastly, for the conclusion, overall, the fundamental and principle of inductor motor are helpful in studying and exploring the operation of any engineering equipment that use the synchronized motor. The project has given us a deeper insight as well as understanding about the operation of inductor motor.
with the aid of a concept that we had learned in electrical machine. Also, the project is essential in helping us to review all the important theories and definition in inductor motor.